Hello everyone and welcome to the Job Shop webinar here at DATRON in New Hampshire. I'll be your host today, Dan Demazure. I'm an application engineer over here at DATRON. And our guest today is Tim Allard from Rapid DTM. I'll tell you more about myself shortly. So just to give you a quick idea of what we're going to be talking about today is a question we get a lot, is why would I want a DATRON in my job shop? Basically the idea is that the DATRON doesn't seem like a really flexible machine. It's got certain limitations in its design. So a lot of people think that they'd be better off with a Haas or a more standard sort of CNC machine. So we've got a real live DATRON owner here in the house to sort of talk about his point of view on why you would actually want a DATRON in your job shop. So without further ado, next slide. I don't have control here. All right, so we'll give a quick introduction. What we're talking about today, we're going to talk about Tim and Rapid DTM. Then we're going to talk about all the reasons you would want a DATRON in your job shop, do a quick summary and recap, and then we're going to take questions from the audience, from you guys. Tim will be glad to answer. If you have questions for me, we'll field them. So, without further ado, Tim? Oh, sorry, no, I'm missing this all up here. Yeah, we're going to talk about why you want a DATRON in your job shop. I've already covered that. This is Tim Allard. I'll let Tim talk for himself.
Yeah, my name is Tim Allard, and I bought a DATRON a few years ago. I do have a job shop just a few miles from this location, and as such, it was a big decision on what type of equipment to purchase that would complement the Haas machines and the ProtoTrack machines and the other equipment that we already had in place. And after looking at everything, it really made sense to add something that would give us more versatility rather than keep us locked into doing things not only the same way that we already did them, but limiting us to just a certain type of job that we always lend ourselves to, rather than opening us up to a different type of work or some different opportunities. And the DATRON has definitely worked out in all those regards.
So as you can see here on the screen, there's a laundry list of all of Tim's experience in the industry with injection molding, wax injection molding, rapid prototyping, dental implant milling, et cetera, et cetera. It goes on for a while, but well over 20 years of experience in the industry. And then a little bit about his shop on the next slide. So his company is called Rapid DTM. Sorry about that. Having a technical difficulty. Next slide. So there we go. So you could just give a bit of.
Yeah, so that, as a job shop, we are primarily focused, like most shops in this area, we do a lot of aerospace and defense work. But as a job shop, we never really know what's going to come in from one day to the next. We do a lot of aluminum milling, we do a lot of plastic milling. We do mill some steels, some stainless steels, titanium. You really never know what's going to come through the door from one day to the next. So you've really got to be tooled up. The hardest thing in this business is to say no when an opportunity comes your way. So you really want to set yourself up to a degree that you can take in different types of work that come your way and do them well, do them efficiently, and really open up some of those capabilities. So we've been doing aerospace and defense work for quite some time, but we really do all sorts of things. We've developed some of our own products. We've done some automotive stuff, really all kinds of things. I had a guy come in today that's got a new product coming on the market that wants us to machine some parts out of S7 steel. So you just never know.
All right, right, so first and foremost, we're going to jump right into probably the number one reason that comes to everyone's mind when they think, why would they want a Datron? It's because of the high RPM spindle. So I'm just going to start out, and Tim's going to chime in with his sort of real life experience as we go by. And this is sort of, in Tim's words, having 40,000 RPM on tap can be a game changer for efficiency. And you sort of said, you know, over a 1/4 inch tool diameter, it might not be that big of a difference necessarily. But under a 1/4 inch is where it can make a huge difference.
Make a huge difference, really, and that's really because, especially when you're machining aluminum, you know, the general rule of thumb in aluminum for most tool companies, they're going to want you to run at 1,000 surface feet. Most people can never get there with tools under a 1/4 inch in diameter. They just don't have the RPM to do it. So they're already making compromises with feed rates in order to, you know, utilize. They basically have to set for the surface footage that they can hit with the spindle speed that they have, and then that lowers the feed rate down accordingly. So to really maximize the use of that tool, if you can get up to 1,000 surface feet, then you can really make some efficiency and really utilize those tools. And we found that they cut better. Obviously, they cut faster. Especially if you're doing a lot of 3D work. We don't have a whole lot of it shown out here. You know, some stuff on this part here. If you're doing a lot of 3D milling, those guys out there that know 3D milling, where they're generating really big CNC programs, it can be a big deal if you can double your feed rate and get that part done that much faster. It can mean the difference, like we were talking about the other day. It can mean the difference between getting, you know, 2 jobs done a day or getting that third piece kicked off before you go home at the end of the day.
You were talking about how, just for a frame of reference, Tim has a 30,000 RPM Haas VF1,
Right.
which 30K is pretty high for a Haas. If you don't know, if you do own a Haas, then you probably have 12, 15,000 maybe on tap. So you were talking about just making the step from 25,000 to 35,000. It doesn't sound like a huge amount, but that ends up being like over 30% more efficient.
30%.
So just having that available to you can make a big difference. Yeah, how many jobs you can get out in a day. So I listed here on this page, here's a prime example, going to Harvey Tools website, using I have 16th here, but I think it's actually 3/32. I had to correct that. So for frame of reference, 1,000 surface feet per minute on a 3/32 tool was 41,000 RPM, and that's Harvey's recommendation. So we can come pretty close to that on a Neo spindle. That's 40,000 RPM spindle. We actually have spindles that go up to 60,000 that you could achieve 41,000 RPM on, and that would be, for their feet per tooth recommendation, 158.4 inches per minute, versus if you had a Haas with a 12K spindle, that would be 47.5 inches a minute. So we're looking at over 3 times faster. So it can be a pretty dramatic difference, you know, when it actually comes down to using micro tooling. You know, we're not gonna lie about over a 1/4 inch. It might not be as efficient, especially if it's maybe steel or something like that, where it just doesn't make as much sense. But if you need efficiency for the small diameter tooling stuff under a 1/4 inch, it can be a total game changer.
It's a big deal, and there's a lot of jobs that we get that other shops can't compete with us because we're just going to crush them on cycle time. You know, we're running tools, you know, 1/16 of an inch, 1/32 of an inch. We're machining, you know, aluminum with those tools. We're just killing it.
Yeah. So the other standout thing is the HSK tool holder. So on Tim's machine, he's got a 3 kilowatt jam-in spindle. It's actually the same one that we have here on this ML-Cube. And that uses HSK 8025 format. And I'll let you talk a little bit about the advantages of that compared to, what do you run on the Haas?
The Haas is BT30.
Yeah.
Which is just it's a taper shank tool holder, very similar to a lot of people are running Cat 40, Cat 50, BT30. The problem with that design, and the reason that the industry's really sort of very, very slowly migrated away from it, is that the clamping point is on that taper.
Yeah.
It's a contact point on the taper. I never really fully contacts the entire taper.
Whereas HSK is on the face as well as the
Right.
taper.
Yeah, and that's why, some of the Cat 40 systems have now gone to what they call a big plus spindle, which gets up closer to being on that flange. But it's just a much more rigid setup being an HSK. And really, any machine that you look at out there, anybody that's really into it, any of the microns, the DMGs, those guys, they're all running HSK stuff.
Right.
And the reason is it just flat out runs better. It's more rigid.
Yeah.
These shunt holders, this shunt hydraulic holder, they're awesome. You
Yeah.
get, very little run out. So you get a better surface finish. And, as a job shop owner, one of the reasons I like tool holders that run nice, especially when I'm winding them up the way that I am, is that your spindles last longer.
Yeah.
Because run out, kill a spindle.
Yeah. Actually, one fun thing that I learned that I just wanted to throw in there that I didn't realize before is that since HSK is clamping from the inside, the faster that this goes, centripetal force is actually causing the clamping force to increase. It's trying to spread the fingers that are clamping onto this. So inherently, it's better than having a full stud design where it's pulling up. So there's even just from the base level, it's more efficient. But when you get down to this particular design, one of the other advantages is how little run out it has. Shunk Tribos advertises less than 3 microns run out, so about a tenth of a valve. I've measured ones that are lower than that. That's just their guarantee. But because there's so much mass here to spin up, it spins up faster than I would say
Right, a lot less mass than your VT30s, your Cat 40s, your Cat 50s.
yeah.
Especially those spindles, they got the drive lugs, usually outboard on the spindle, causing balance issues.
So this is smoother running, so it means better tool life, better surface finish, better spindle life. So altogether, it's a really nice system, and it's perfectly adequate for the size tools you're working with. You don't need it to be bigger than that. There's just no point. And then something that was really interesting that Tim and I had talked about before is for some demanding applications, some prints will call out no high volume milling. I don't know if you can elaborate on that.
Right, we are starting to see that mostly in the aerospace industries. Stuff that's going into space or seeing dramatic temperature differences. They are finding, basically with aluminum parts, we do a lot of aluminum, that they're seeing less movement in the parts over these temperature changes based on whether the type of machine strategy that you're using. So when you're using high volume machining, you're getting all that material out there with really deep depth of cuts, and you can get it out of there quickly, but it tends to leave, it seems, more residual stress in the material than it does if you're taking lighter, higher speed cuts to get that same material out of the way.
And so, yeah, the point with that is that high RPM becomes valuable because you might be you could use, let's say, a half-inch diameter tool, but because of this no high volume milling, you're really better off using an 1/8-inch tool or something like that. So that's where the RPM can become really invaluable at your disposal. Okay, we're going to move on to the next point now, which is the MQL, which is minimum quantity lubrication, if you're unfamiliar with it, and dry machining. So, first and foremost, a lot of people, they're just accustomed to the flood coolant systems that come on pretty much every typical VMC, and they're used to the level of maintenance that comes with it, but there's a major benefit to not having to deal with flood coolant, and that is not having to top off, test, filter, dispose of the coolant. There's no degreasing of the parts afterwards, and you never have to deal with foaming overflow of foam from the system or somebody topping off the system and having it flow over the floor. Not that that's ever happened to you.
Yeah, right. It's pretty much everybody out there that has a flood coolant system or has a number of machines or employees filling up their coolant, they flooded the shop. See posts at least once a week on Facebook, people flooding their shop.
Yeah.
It happens.
Yeah.
People forget. But yeah, really, there's a lot of advantages to the MQL system. especially with the ethanol system that DATRON is using. I'd never heard of it, didn't really know anything about it. Thought it was a cool idea, but it really works incredibly well in a variety of materials. And if you're cutting steel, you just depressurize the ethanol tank, and we're using air blast, which most cutter companies are going to want you to use just air on the steel anyways to prevent thermal shock from chipping your tools.
A lot of coatings now need to reach a certain level of heat before they're sort of activated, where they're most efficient in terms of their sort of lubricative qualities. So I can see it sort of makes sense just to run air blast. I know actually CBN tooling, cubic boron nitride, you can't use flood coolant at all because of the thermal shock issue where it will just cause it to crack and explode.
Yeah, it's a big deal, and you know, I experience this. You call cutter companies, you know, say, you know, I'm cutting this material, I'm cutting P20 with your cutter, you know, and your speeds and feeds, and the tool's chipping, what's going on? First question they ask is, you running coolant? You know, don't run coolant. You know, can you use, they'll ask you, can you just use air blast in your machine? So yeah, it's a huge thing. You know, there's a lot of things that you don't even really think about until you really start using the system. I'm a super neat freak. Everybody that knows me knows I'm a neat freak. I have a really super clean shop. Using machines with flood coolant, and you just get that sticky residue in the air. It shows up in all your HVAC filters. It's on the surfaces. It's just, no matter what you do.
You know that smell when you work
always
into
there.
a shop. You can smell it in the air.
Yeah, that's why, you know, machines like that have mist collectors on the top, you know, to
Still
try
doesn't
and
get
capture
it at all.
that. Yeah, it's just, it's not good. You know, you look at the machines, there's just sort of this petri dish underneath the machines of that sticky, nasty kind of residue underneath there. It's just a lot easier with the DATRON, a lot easier to keep things clean. It's nice.
And then one story that you told me, not to get off track too much, but you had mentioned somebody in your shop had topped off one of the machines incorrectly. There's what, a top off value and a new sort of.
Yeah, well, this is one of the things about that some people don't even fully realize with coolant systems. So you get coolant, you get a bucket of concentrate, and it's mixed with water at some ratio. And usually it's right around 6 to 8%, somewhere around there, maybe as much as 10, depending on the brand of coolant that you're using, it varies a little bit. And that's for a fresh charge. So what happens is as you're running, or as the machine's sitting, you know, overnight and it's running during the day, most of what you burn off is the water. You lose it to evaporation or to the heat, you know, during the cutting process. So when you top off coolant, you top it off at a lower mix, like 1 or 2%, versus the 6 or 8 that you did a fresh charge at. And again, you also have to think about how much coolant you have in the tank. So if you're just topping off a little bit, you can top off at 1 or 2%. But if really half the tank's gone, you probably want to be at like 4 or 5% to maintain that concentration level target that you're looking for. And that's what you have to check with the refractometer. But to get back to the story, if you're not paying attention to these details and you charge it too light, which happened to me, you get rust and you get lots of rust. All the tool holders were rusty, the vices were all rusty, and you can really never make rust go away. You know, we tried scotch brightening everything, cleaning it up, oiling it up, but it's never really the same after that.
It's cancer. It's cancer for your machine.
Rust is like cancer that way, you know. It's a hard thing to get rid of.
Because you end up getting rid of the tool holders that were rusted?
Yeah, we replaced a bunch of tool holders. And really, as I said, clean everything down, take the vices out, scotch spray everything, oil everything, you know, to try and stop it from where it was. But it had run like a cycle or two and then sat overnight, so it was just a mess in the morning.
So that's something you never have to deal with on a DATRON, so that certainly isn't too bad. The next thing that the MQL sort of does for you is that it allows for some different work holding capabilities. Namely, two things. If you use double-sided tape, you had mentioned that some applications you're a big advocate for vacuum work holding, but sometimes you have to use some sort of adhesive.
Sometimes you gotta use tape, you know, most of the guys out there have been doing this for a while. They'll have used some double-sided tape at some point to hold something down, whether they're skimming a plate flat or whatever they're doing. And once you hit that tape with the coolant, it sticks for a little while, but it, you know, in a very short period of time, maybe 10, 15, 20 minutes, the oils and stuff in that coolant will start to break down that adhesion. And you know, this part here that you have on the screen with those tiny little fingers, that part was very, very difficult for us to produce in the Haas, because I have to use tape to sort of keep those fingers in place, keep them down. Number one, you don't want the cutter to grab them at all, because that's mic 6, so that'll just break.
Yep.
Or if it vibrates, you get a really ugly surface finish on it.
So that's actually another instance where you need to utilize sort of low volume milling versus the high volume milling, because a big tool, too much tool pressure, just too violent, basically break the finger off.
Yeah, if you look at the cutter marks on here, you can see that, you know, I used a pretty small tool to finish those things out.
Yep.
And it holds awesome with the tape in the DATRON, but you know, it still has its limits, so I wasn't pushing my luck.
Yeah, yeah. But the other thing is our style of vacuum work holding, which is kind of, I wouldn't say unique. It is available for other machines, but with ours, it's sort of leveraged to the full extent. Our vacuum work holding plus the anti-coil system plus the high-speed spindle all work together sort of harmoniously, I guess you could say. Which I know you weren't a believer in vacuum trucks. The first time I met you, you said, I don't trust a vacuum truck.
I've been doing this for a long time. I've tried some different vacuum shops and failed, and tried to make my own, and they never really worked real well. So yeah, I never had a lot of success over the years. Tried the ones with the gaskets where you're trying to get the gasket to lay in the groove, and it never really works that well. Your system, you know, between the chuck design and that layer of cardboard, that sacrificial layer that allows the vacuum to pull through it. I mean, not only does it make the chuck universal, it just works so much better.
Yeah.
You know, I say it makes the chuck universal because if you have to use that gasket stuff, you're really sort of dedicating the chuck to a specific job. And that may be great if you're in the production world, you know, and that's all you're going to do, but we're doing something different every day.
Yeah. And that paper wouldn't work on a blood cooling system because it would just swell and deteriorate and get absorbed and sucked through and clog pores. So it's part of why we can sort of get away with that, is the ethanol is evaporating basically as soon as you're spraying. So just something to point out there. Additional benefits from non-aqueous coolant. I had to look up my big words for this presentation. Does not affect hygroscopic materials like nylon, ABS, polycarbonate, etc. I wasn't really aware of this, but you mentioned you had an issue with it.
I had an issue with it, and I have had issues with it over the years. In previous shops that I ran and in my current shop, where you have to be careful with we cut Semitron 225 quite a bit, which is anti-static Delrin flavor of plastic, and it soaks up coolant, and significantly and fairly quickly. Besides, so it's like I said, I was telling you about a Delrin part that I had cut overnight in the machine, and came in the next morning, and the part had a pocket in it, in this blind pocket, where the coolant was trapped in there overnight, and the part had swelled up so badly that it had popped out of the vise. I had learned from that experience and really kind of avoided that, but then a couple of years ago I had a job in a similar material in the Haas, and it was a fairly quick running job, but it still soaked up enough coolant where it was throwing the part out of tolerance. It was actually causing some of the walls to bulge just enough where it was messing things up, and I didn't really catch it until I was in inspection at that point.
So
we start over in the DATRON when we run that hardware.
And the other side point with an MQL system is that there's no additional hardware pumps or tanks I mean, any of the equipment I guess you need to deal with it.
Liquevacs.
Yeah, all that stuff. So it means your machine has a smaller footprint. We're gonna touch on that
Back to speedy dry.
and speedy dry, pig mats, all that stuff.